So on Friday we talked about some vocabulary that was associated with lines. Today we're going to focus on now graphing those lines. So we mentioned some different possibilities for slope on Friday, so we're just going to go through them. Again, when we have an increasing or a positive slope, if we had a graph of a line, that just means as you go from left to right, your line is increasing as you go left to right. In a table, if we had an increasing or a positive slope, as our x values increase, our y values increase as well. So y values increase. In an equation, if we're looking at a positive or an increasing slope, if we're looking at our regular or the most popular y equals mx plus b, we know we have a positive or an increasing slope if this m value, the number in front of that x, is positive. So then with our negative or decreasing slope, it's essentially all the opposite. So we have our graph. The graph of our line would be decreasing as you go from left to right. With the table, as the x values increase, the y values are decreasing. Or you're subtracting the same thing every time. And then in an equation, we'd have a negative or a decreasing slope if our m, that slope value, the number, whatever number's in front of x, is a negative number. Okay, so both of these, increasing and decreasing, are dealing with the diagonal lines. There are some other types of lines that we can encounter. One would be when we have a zero slope. This is where we have a horizontal line. Okay, so it has a zero slope because if we think of slope as rise over run, in this case, our line, when it's horizontal, there is no rise. It's only running. It's only going horizontal. So it would essentially be 0 over some number. Let's say 4, whatever 2 points we chose. And 0 divided by anything will always be 0. So when it's a horizontal line, the slope is 0. In a table, when we have a horizontal line, our graph has the same y value for every single point because, again, there's no rise. It's not changing. So the y value will always be the same as the x value changes. So the y value is the same for all points when we have a horizontal line. And because of that, since when we have a horizontal line, it's just the same y value horizontally, the equation of a horizontal line would be y equals some number. So in this case, like y equals 3. Because since slope is 0, if we looked at our mx plus b form, m would be 0, and 0 times x would just be 0. So you're just left with that b value, just y equals a number. So if there's no x's around, that means it has a 0 slope. And then our last possibility is undefined. This is when we have a vertical line. So a vertical line has an undefined slope because, again, if we look at our rise over run that we use when we're finding slope, in this case, our line only has rise. It's just going up and down. There is no run. It's not changing left to right. So it would be like 4 over 0, and we can't divide by 0, which is why it's undefined. It's okay to have 0 in the numerator. You can do 0 divided by a number, but you can't divide something by 0, so that's why it's undefined. So with a vertical line, our line has the same x value for everything as it goes up and down. So in a table, all the x values would be the same as the y values changed. And then since a vertical line just has the same x value, for the equation it would be x equals a number. So like x equals 3. So when there's no y at all, and it's just x equals a number, that is a vertical line. All right, so now we're going to talk about some different ways we can write equations of lines. I know you guys like slope-intercept, or the y equals mx plus b, but there are some other ones. But we are going to start with slope-intercept form. So what it looks like, y equals mx plus b, it's called slope-intercept form because we are told the slope, which is whatever that m value is, and we're told the y-intercept, so hence slope-intercept. And remember that b value is the y value of the y-intercept. The x value is always 0 because any point on the y-axis will have an x value of 0. Okay, so for example, y equals 3x plus 7. For this case, our slope is 3. If you want to think about it as 3 over 1, then it's easier to see kind of the rise over run deal. So this means we would go up 3 and right 1. And then for our intercept, it's a positive 7, so our y-intercept would be the point, 0, 7. Okay, so slope-intercept form is handy because it's easy to graph in your calculator because y is already by itself. It's also easy to graph by hand because you're given a point, the y-intercept, and you're given the slope, how to find other points. So we'll do it by hand first, and then, or I guess we'll do it using our calculator first, if you guys can get your calculators out. So to use your calculator, again, you just need to make sure that y is by itself. If it's in slope-intercept form, y should already be by itself. And then if you hit the y equals key in your calculator, it should be like in the top row right underneath the screen, top left, hit y equals. So y equals in your calculator. And then you just type in the equation. So it already has y equals, so you would just type in 3x. The x key, okay, so again, to do the x, you hit the button next to alpha, x, t, theta, n. That's your x, and then plus 7 is ours. And then you can hit graph, and it'll graph it. Sometimes on a graph it can be difficult to see, on your calculator it can be difficult to see specific points. So if you want to see specific points, you can hit the second button and then graph, and that will take you to a table. And then from that table, you can see a bunch of points, plot those points, and connect the dots. So second graph brings you to the table. Okay, so that's one way. Again, you can just look at the table, scroll up and down with the arrows to see points to help you graph. If we want to do it by hand, you would first plot the y-intercept. So in this case, it's the point 0, 7. So 0, 7. And then you'll use your slope, the rise over run, to find more points. Okay, so if we start at our y-intercept, we set our slope up here. It was 3 or 3 over 1. So that means it has a slope. For rise over run, you would go up 3 since it's positive, and right 1. So we go 1, 2, 3 over 1. Okay, but now I've kind of run out of graph already, but I can still go the other way if you just do the complete opposite. So instead of going up 3, right 1, you can go down 3 and left 1, and just make sure, again, it follows the pattern of the line. You shouldn't end up with a point over here because that's not part of the line. So go down 3, 1, 2, 3, and left 1. So see, that point is still in line with the other two. Down 1, 2, 3, left 1. Down 1, 2, 3, left 1. Okay, getting at least 3 points to help you graph your line is best. The more the better, though. Then you just connect your dots here. And we always have arrows at the end of our lines because lines go on forever. Okay, and then you can always double check. So if we look at our equation, our slope, our m value, is positive, which means our line should be increasing, which it is. If somehow you ended up with a graph of a line that had a negative slope, you might want to double check something because our equation was positive mx, which means it should have been increasing. Okay, so that's slope intercept. We go on to the next page. There's another form called standard form. And this is where we have the x and y term on the same side of the equal sign, and then it equals your constant, or it equals a number. So it's x term plus y term equals a number. So this form, standard form, can be useful because it is easy to find both the x and y-intercept. Slope intercept form is really easy to find the y-intercept, but the x-intercept takes a little bit of work. For x and y-intercepts, so let's do the x-intercept first. For the x-intercept, we know this is where y equals 0. So if we take our equation that we have over here, 3x plus 6, then instead of 0, or instead of y, we'll plug in 0 for y, equals 12. 6 times 0 is just 0, so we'll be left with 3x equals 12. How do I get x by itself? It's not a trick question. How do I get x by itself? Divide by 3 on both sides. So we're left with x equals 4. So that would be a point. We'd have the x-intercept of 4, 0. Then we can do the same idea with our y-intercept, where we plug in 0 for x. So 3 times 0 plus 6y equals 12. 3 times 0 is just 0. So we're left with 6y equals 12. And to get y by itself, we would divide by 6. So y equals 2. So our y-intercept would be the point 0, 2. Okay. So it's useful because finding both the intercepts are pretty straightforward. And then graphing, if we want to graph by hand, if we find both of the intercepts, those are 2 points, and really that's all we need to graph a line. You need at least 2 points. So by hand, you could find the x and y intercepts. and plot them. So our x-intercept was 4, 0. And our y-intercept was 0, 2. Okay, and then if you want to find more points to plot on this line, we could just use our slope, our rise over run. So going from my y-intercept to my x-intercept, I go down 2, 1, 2, and I go to the right, 1, 2, 3, 4. So I could do that some more times if I wanted. Down 2, to the right, 4. Then we connect our dots, putting arrows at the end of our lines because lines go on forever. Okay, so standard form you can't plug directly into your calculator because y is not by itself. However, if you guys prefer slope-intercept form and you want to be able to use your calculator, you can rewrite your equation in slope-intercept form. You do this by just solving for y. So this is like what we did last week when it was on our quiz. So if we had our equation from up above, 3x plus 6y equals 12, and we want to get y by itself, we have to deal with any addition or subtraction first. Remember, do the order of operations in reverse. So we have this 3x that's being added to the y term, so you can subtract 3x from both sides, which will leave you with 6y equals 12 minus 3x. And then y is being multiplied by 6. So to undo that multiplication, we would divide everything by 6. That would leave you with y equals 2 minus 1/2, because we can simplify that. X, if you want to flip it so that it's in the mx plus b, right now it's going to be plus mx. You can do that. Just remember the sign that's right in front goes with the terms. This would be y equals a negative 1/2 x and plus 2. Okay, then you could use your calculator to graph it, or you could plot your y-intercept and then use the rise over run to do the slope. You get a couple points. Either way, you'd get the same line, same graph of a line. So it's kind of up to you if you want to just use the two intercepts, or if you want to solve your equation into slope-intercept form. You have options. Okay, and the last equation, or the last form that we can write an equation in is called point-slope form. So this is where you just have any point that's on a line and the slope. So here, the m is still representing your slope. But then we have this x1 and this y1 term. This is representing a point on your line, where it has an x value of x1 and a y value of y1. So for the example next to that, our slope would be negative 2. So it's like negative 2 over 1. You want to think about it like that. It's easier to see the rise over run. It's negative, so that means we'll go down 2. But we always go to the right 1. And then we have a point on the line. So if you notice in the general form, it's always y minus y1 and x minus x1, which just means you're going to take the opposite sign. So in our case, to get a point, since this is a plus 4, the opposite of that would be a negative 4. And then for our y minus 3, since it's a minus 3, the opposite of that would be a positive 3. So it's opposite, ooh, I'm running to the desk, opposite signs. Okay, so how it's useful, it is easy to write as an equation if all you know is the slope and a point, not necessarily one of the intercepts. It's easy to write to get this equation. And it's easy to graph because you know the slope and you know a point. So if we want to graph by hand, we can first plot the point that's given in that point slope form. So plot the given point. Remember, it's opposite signs. So we said our point was -4, 3. So -4, 3. And then use your slope, the rise over run, to find some more points. So we said our slope, we're going, since it's -2, that means we're going to go down 2 and right 1. So start from my point, down 2, right 1. Down 2, right 1. Down 2, right 1. Then again, if you want to go the other way, you just do the opposite. So up 2, left 1, making sure it just falls in line with the points you already have. It has to be a straight line. And then we connect our dots, putting arrows at the end because lines go on forever. Okay, or again, if you want to do it in your calculator, if you want to be able to use your calculator, that's fine. You just have to rewrite this equation in slope-intercept form. So again, to do that, we would distribute and solve for y. So we had our original equation, which was y minus 3 equals -2x plus 4. So this -2 out in front needs to be distributed. So we have -2x minus 8. And then to get y by itself, you'd add 3 to both sides. Okay, so then it's in slope-intercept form, so you could either use your calculator, look at the table, or you can plot your y-intercept and then use the slope. So if you guys really like slope-intercept form and you just want to keep using that, that's fine. You just have to do some extra steps to rewrite some equations in that form. But it is possible to graph lines straight from point-slope form and standard form as well. So it's just a personal preference, whatever you want to do. Okay, so I think, let's see, if we look at these next 4 examples, 1, 2, 3, and 4, I want you guys to take a couple minutes and graph the lines. So you can, again, use your calculator to help you. You can look at the table, or you can plot a point and use the rise over run to find the slope. Whatever helps you. I have some tables there if you want to write down some points from your table. But I just need you to graph those 4 lines in whatever way makes the most sense to you. Okay, so I'll give you a few minutes to graph these lines, and then we'll go over them in a minute. With these, so with example 1, y was already by itself. This is in slope-intercept form, so if you wanted to just plug this in your calculator using y equals, you could do that and look at the graph or look at your table to find some nice points, so that is an option. Or doing it by hand. Again, this +2 here is your y-intercept. Y-intercept always have the x value of 0 and the y value of that b, or whatever that b term is. So 0, 2 would be our first point. You didn't have to use these tables. I just wrote them here if you wanted to use them to organize. So I plot my point 0, 2. And then we use our slope. So our slope here was 2 over 3. So with our rise over run, that means you'd be going up 2, right 3. So we started our point at our y-intercept, up 2, right 3. up 2, right 3. Up 2, right 3. Do that a few times so you get a nice number of points, and then connect your dots. Arrows at the end of our line. Okay, any questions on that one? That was in y equals mx plus b form, so I know you guys are probably most familiar with that. If we look at our second one, 3x minus 5y, if you wanted to rearrange this so it's in slope-intercept form, that's fine. You should have ended up with y equals 3 over 5. 3 over 5x minus 1. So if you did that, then you can use your calculator or use the method that we use for example 1. Or remember, when it's in the standard form, it's really easy to find the y-intercept and the x-intercept for x equals 0 and where y equals 0. So we could just do that, or we plug in 0 for x. So we'd have negative 5y equals 5, divide by negative 5, y equals negative 1. And then plug in 0 for y. Divided by 3. So x equals 5/3. You have your 2 points that way. So 0, negative 1. And then 5/3 would be just under 2. 0. You can connect your dots that way. Okay, so either way, either find the intercepts or just solve for y. Anyway, works as long as your line looked the same. With example 3 and 4, so notice with example 3, it's just y equals negative 4. Do we have an x in sight? No, there is no x. So this one is just y equals a number. This is when we have a horizontal line. So with horizontal lines, if you were to type in your equation into your calculator under y equals, just type in negative 4. And you looked at your table, all the y values would be negative 4, no matter what x value you chose. So that means you just go to the y value of negative 4, and you draw a horizontal line. Then example 4, this one is just x equals a number. There is no y. When it's just x equals a number, this is our vertical line. This one you cannot plug into your calculator because there is no y. So you can't use your calculator to help you for this one, so you just have to be able to recognize when you have x equals a number, that means you have a vertical line. So if you go to the x value of 2, you just draw a vertical line. So all the same x values of 2 as you go up and down. Okay, so that's graphing. Sometimes you can use your calculator, sometimes it's quicker to do it by hand. Just a personal preference, whatever you want to do. Okay, on our last page here, now writing equations. So again, we have some options: point-slope form, standard form, or slope-intercept form. So if we look at letter A, we have a table here. Remember on Friday we talked about how we can find the slope from a table. If we look at our y values, what are we doing as we go from y value to y value here? Yeah, we're subtracting how much? 2. And then what are we doing with our x values? Adding 1. So x values are the run, y values are the rise. So if we have our rise over run, it'd be negative 2 over 1. So we have our slope, negative 2 over 1. And then with point-slope form, all we need is another point, and we have a list here of 4 possible points. You can really choose any point you want. I'll just choose the first one, and we can put it in point-slope form. So it'd be y minus the y value equals our slope. Then in parentheses, oh geez, sorry. Slope, and then in parentheses, x minus the x value. So that's an option, point slope form. If you want to find the y-intercept and write it in slope-intercept form, we were adding 1 as we went down with our x values. We know that the y-intercept happens when x equals 0. What do I have to do to get from 1 to 0? Subtract 1, right? It's just the 1 point that whatever came before. So we want to subtract 1. And then here we were subtracting 2, subtracting 2, subtracting 2. So if we go backwards, we would add 2 to get 7. So then you could write your equation as y equals mx plus b. So again, you have options if you want to do point slope or slope intercept. Either way works. You'll get the same. If you were to distribute that -2 and add the 5 over, you would end up with the same equation. We take a look at letter B. We have a line that's graphed. We need to find the equation. So here it's pretty easy to find our slope and our y-intercept. So looking at our graph here, what is our y-intercept? 4. Yeah, this point right here is our y-intercept, the point 0.04. Okay, now when we find our slope, we got to be careful because what are the increments on our graph counting by? 2. So when we find our another nice point here, we do like this one, 2, 8. This is going up to 4, and then to the right 2. So if we do our rise over run, it's really 4 over 2, which is just 2. So then we can write it in our slope-intercept form. Y equals mx, so 2x, plus b, so plus 4. Okay, for our next one, a line has a slope of -1/2, so that's our m, and a y-intercept of 0.5, so that means 5 is our b. If we have the slope and the y-intercept, you can go right to slope-intercept form. So y equals our slope, mx, plus our b, which is 5. Okay, with letter D, this one I'm just giving you 2 points, -1,6 and 3,12. So we could use point slope. We have the 2 points already. We just need to figure out the slope. So if we look at our rise, that's from going from y value to y value. What did we do is we went from 6 to 12. What did we add? 6, so plus 6. That's our rise. And then for the run, as we went from -1 to 3, what did we do? Added 4. So we'll have our slope would be rise, which is 6, over 4, which is our run. We can simplify that if we want, 3 over 2, but it's not that big of a deal if you don't. So then using our point slope, again, you can choose either point. It doesn't matter what point you choose. So we can have y, I'll just do the first one. So we can do y minus the y value, so -6, equals our slope, and then in parentheses, x minus the x value, which in this case would be minus a -1. Yep, you could write it as x plus 1 as well. I just wanted to write it so you could see that it's the opposite. But yep, if you want to write it as x plus 1, that's fine. And then our last one, a line has an x-intercept of 3 and a y-intercept of 7. So this is giving you 2 points. It's just not written in the point form there. But if we have an x-intercept of 3, that means the x value is 3 and the y value is 0. And then a y-intercept of 7, we have an x value of 0, y value of 7. So we know our y-intercept, which is 7. That means that would be our b value. Keep that. We just need to figure out the slope. So if we do rise over run, so for our rise, 0 to 7, what did we do? We added 7. And then for the run, 3 to 0, what did we do? Subtract 3. So our slope would be rise over run. So our slope-intercept form would be y equals mx plus b. Okay, so you just have to be able to find these different things like slope and intercepts from different formats.